A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron. A chemical fingerprint that really defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to. If these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that just didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Imagine finding a fingerprint that doesn't match any person on Earth. That's what astronomers found in the light from 3I Atlas. Almost as soon as it crossed Jupiter's orbit, spectrographs detected strong signals of atomic nickel streaming from its coma. But the real shock wasn't what was there, it was what was missing. There was virtually no iron. This isn't just unusual, it's chemically bizarre. In every meteorite and comet we've ever studied, nickel and iron are cosmic partners, forged together in the hearts of dying stars and locked into the same minerals. When a comet heats up, they should be released together. Yet, data from the Very Large Telescope showed nickel vaporizing off the object, while iron was a no-show. Harvard astrophysicist Avi Loeb was the first to publicly highlight how unnatural this is. He argues that separating nickel from iron requires industrial processes here on Earth. In space, it's unheard of. It's like finding a gold ring without any trace of the other metals typically alloyed with it. This single chemical clue is so potent that it forces a profound question. Are we witnessing a freak of nature, or is this a deliberate engineered signature? Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma, and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in late 2017, astronomers detected one Oumuamua. At first it seemed like an asteroid, but its behavior was deeply strange. As it swung past the sun, it began to accelerate, pushed by a force that wasn't gravity. The problem? There was no visible outgassing, no tail, no coma, none of the typical rocket-like effects a comet uses to speed up. Oumuamua left nothing behind. Its light curve also suggested a bizarre shape, perhaps 10 times longer than it was wide, like a cigar or a flat pancake. The scientific community scrambled for an explanation: exotic ices, hydrogen outgassing, fractal dust. But no single natural theory fit all the data. It was into this debate that Harvard's Avi Loeb stepped, arguing that Oumuamua's shape and acceleration were consistent with an artificial object, specifically, an ultra-thin solar sail designed to ride the pressure of starlight. The idea caused a firestorm, but it cemented a critical precedent. When objects from other stars arrive, we shouldn't assume they'll play by our rules. Oumuamua prepared the scientific world to ask bolder questions. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So if not aliens, what could possibly create pure nickel vapor in space? The answer might lie in one of the most violent events in the universe, a kilonova. This is what happens when two neutron stars, the ultra-dense corpses of massive stars, spiral into each other and collide. The resulting explosion is so powerful, it forges heavy elements through a process of rapid neutron capture known as the R process. In 2017, the gravitational wave event GW170817 gave astronomers their first direct look at this process, confirming that neutron-star mergers create vast quantities of heavy elements like strontium, gold, and platinum. Nickel is also created in this cosmic furnace. Crucially, depending on the chaotic conditions of the explosion, some models predict that patches of the ejected debris can be exceptionally rich in nickel while being poor in iron. These aren't the slow-cooked metals from normal stars. They are forged in seconds and blasted into space. If 3I Atlas condensed from such a cloud of debris, it would carry a chemical fingerprint completely alien to our solar system. This provides a natural, albeit spectacular explanation for its strange composition. Asymmetric supernova theory. So, there's another natural forge out there in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. You see, not all stars meet their end in neat spherical explosions. Some, well, they rip themselves apart in these lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example of this. X-ray maps from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. And if nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. So, if 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, the path of 3I Atlas through our solar system is so unusual it's hard to ignore. Avi Loeb and his collaborators ran the numbers, calculating the probability that a random interstellar object would have a trajectory that takes it unusually close to Venus, Mars, and Jupiter, all in a single pass. The result was a probability so small it's almost zero, about 0.005%. That's like flipping a coin 15 times and getting heads every single time. To Loeb, this really strains the definition of coincidence and starts to look like a pattern. The object's path is nearly flat relative to the solar system's plane, but it's moving backward or retrograde against the flow of the planets. This combination allows it to skim past the inner worlds in a way that looks suspiciously like a survey flight. Critics argue that in a vast universe, rare events are bound to happen, but Loeb counters that if the odds are 1 in 20,000, and we've only seen 3 interstellar visitors so far, something doesn't add up. When you combine this improbable trajectory with the engineered-looking metals, Loeb argues it's time to take the artificial origin hypothesis seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. What if we've been looking for the wrong kind of message? For decades, the search for extraterrestrial intelligence has focused on radio waves and light signals. But what if an advanced civilization chose to send a message encoded in matter itself? This is the provocative idea that the anomalies of 3I Atlas force us to consider. On Earth, scientists are already developing methods to store information using the ratios of isotopes in molecules, creating a kind of atomic fingerprint that can be read with a mass spectrometer. In biology, DNA stores vast amounts of information in a sequence of 4 chemical bases. Some theorists now wonder if the periodic table itself could be used as a sort of cosmic QR code. By arranging isotopes in a pattern that nature would never produce by chance, a message could be baked into a physical object. This message would be incredibly durable, immune to cosmic noise, and capable of surviving for billions of years. Spectrographs are now re-examining every bit of data from 3I Atlas, looking for these hidden patterns. The hunt is on for a fingerprint that says someone was here, and they wanted to be found. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Space Facts. A rare visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, is mind-blowingly huge and moving at impossible speeds. Could this colossal traveler from another star hold secrets that could change everything we know about our place in the universe? Some scientists are terrified by what NASA's data is revealing. The breaking discovery. The astronomical community was stunned when the Atlas telescope in Rio Hurtado, Chile detected a mysterious object moving at incredible speed through our solar system on July 1, 2025. Initially designated A11PL3Z, this faint blip at magnitude 18 quickly drew international attention from observatories worldwide. Follow-up observations by multiple telescopes confirmed something extraordinary. This wasn't a typical space rock but the third confirmed interstellar visitor, now officially designated 3I Atlas. Its hyperbolic trajectory and extreme velocity immediately suggested an origin far beyond our solar boundaries, forcing astronomers to reconsider existing models of interstellar object behavior. The object's sudden appearance sparked both excitement and genuine concern within the scientific community, as its unprecedented size and velocity patterns baffled even the most experienced researchers. NASA immediately mobilized its network of ground-based and space-based telescopes to monitor this cosmic traveler closely, launching one of the most intensive observation campaigns in modern astronomy. The extraordinary nature of this discovery has reignited passionate debates about the possibility of extraterrestrial technology passing through our celestial neighborhood, with some scientists expressing private concerns about what this visitor might represent for humanity's cosmic security and understanding of our place in the universe. The discovery story. How does one spot a needle in the cosmic haystack traveling at impossible speeds? Between June 25 and July 1, 2025, the continuous robotic surveys conducted by the Asteroid Terrestrial Impact Last Alert System began detecting an unusual object with properties unlike anything previously recorded in astronomical databases. Located in challenging viewing conditions near the constellations Serpens Cauda and Sagittarius, the object's initial faint appearance made it extremely difficult to track against the crowded star fields near the galactic center. The automated Atlas system's sophisticated algorithms identified this fast-moving visitor, initially catalogued as A11PL3Z, immediately triggering alerts that attracted urgent attention from professional astronomers across the globe. The object's clearly hyperbolic trajectory and extraordinarily high velocity indicated definitively that it was interstellar in origin, prompting an unprecedented level of international collaboration for detailed follow-up observations. Advanced telescopes from the Canada-France-Hawaii Observatory, Lowell Discovery Telescope, and numerous other facilities provided crucial confirmation data, sharing precise positional measurements through secure astronomical networks. This coordinated global effort enabled detailed orbital calculations that definitively cemented 3I Atlas's historic status as humanity's third confirmed interstellar intruder, following the groundbreaking discoveries of 1I Oumuamua and 2I Borisov that forever changed our understanding of cosmic visitors. A stranger in our midst. What makes 3I Atlas so fundamentally different from everything else in our solar system that scientists are genuinely unnerved? This cosmic stranger immediately distinguished itself through characteristics that challenge our basic understanding of interstellar objects and natural physics. Moving at an absolutely staggering speed of approximately 58 kilometers per second relative to our Sun, it dramatically exceeds the velocities of all previous interstellar visitors, including 1I Oumuamua at 26 kilometers per second and 2I Borisov at 32 kilometers per second. Despite its incredible distance, the object maintains sufficient brightness around magnitude 18 to enable telescopic detection and detailed study by major observatories worldwide. Unlike typical solar system objects that follow predictable elliptical orbits, 3I Atlas traces an extreme hyperbolic trajectory with an unprecedented eccentricity of 6.141, mathematically proving it is gravitationally unbound and destined to exit our solar system forever. Perhaps most disturbing to researchers is the object's premature cometary activity, forming a visible coma and distinctive tail despite being over 4.5 astronomical units from the Sun, much farther than any known comet species begins showing activity. This combination of impossible velocity, extreme trajectory, and anomalous behavior has created profound unease among scientists, with some privately questioning whether 3I Atlas represents something far more extraordinary than a simple frozen rock from interstellar space. The predecessors. So how did humanity suddenly transition from never seeing interstellar objects to detecting 3 in just 8 years? Well, our cosmic awakening began with the shocking discovery of 1I/Oumuamua in October 2017 by the Pan-STARRS telescope in Hawaii. This elongated asteroid-like visitor absolutely stunned astronomers with its mysterious acceleration and complete lack of expected cometary features. The enigmatic object sparked some pretty intense scientific debates about whether it had natural or artificial origins, with a few researchers even suggesting it might represent alien technology. The conversation took a new turn with the August 2019 discovery of 2I/Borisov by amateur astronomer Gennady Borisov from Crimea. This time we saw a more conventional interstellar comet that behaved remarkably similarly to comets from our own solar system, giving researchers their first real chance to analyze pristine materials formed around distant stars. Now, the arrival of 3I/Atlas in 2025 marks the latest and most puzzling chapter in this rapidly expanding field, combining disturbing elements from both predecessors while introducing entirely new anomalies. With a significantly larger estimated size than both previous visitors, clear cometary activity, and record-breaking velocity, 3I/Atlas really does defy easy categorization. Each successive discovery has just exponentially expanded our understanding of the galaxy's vast population of wandering objects ejected from distant planetary systems, suggesting a dynamic and honestly potentially threatening interstellar environment filled with cosmic refugees from stellar catastrophes. The cosmic journey. So where exactly is 3I/Atlas headed? And should humanity be concerned about its trajectory through our solar system? Well, this interstellar wanderer follows a precisely calculated path that brings it uncomfortably close to multiple planets, though it keeps enough distance to avoid being captured by gravity. It was first detected approaching from a tough viewing angle, which kept it hidden near the sun's glare. The object's hyperbolic orbit will carry it to perihelion on October 29, 2025, passing closest to our star at 1.36 astronomical units. That's roughly 203 million kilometers away. While 3I/Atlas will never get closer than 1.8 AU to Earth, so our planet is safe from any kind of direct collision. Its trajectory aligns almost perfectly with our solar system's ecliptic plane. Astronomers calculate that's only a 0.2% probability of happening by random chance. This suspicious alignment gives the object optimal viewing opportunities of all the major planets, including close approaches to Mars and Jupiter, which would be just ideal for reconnaissance purposes. The path offers some unprecedented opportunities for detailed study by existing planetary orbiters and Earth-based telescopes, but it also raises some unsettling questions about whether such precise planetary encounters could really result from just natural gravitational interactions. After its solar passage, 3I/Atlas will begin its permanent departure from our cosmic neighborhood, carrying whatever information it may have gathered back into the vast emptiness of interstellar space, never to return to our vicinity again. A scientific goldmine. Why are astronomers calling 3I/Atlas the most scientifically valuable interstellar object ever detected, despite their concerns about its true nature? This cosmic visitor presents just unparalleled opportunities for studying authentic interstellar materials and processes with a level of detail and duration we've never had before. With its substantial estimated size, ranging between 1 and 12 kilometers in diameter, potentially making it the largest confirmed interstellar object and sustained cometary activity producing analyzable dust and gas, researchers worldwide are really mobilizing to extract maximum scientific value from this fleeting encounter. The object's extended visibility period means that major observatories and space telescopes, including the James Webb Space Telescope and Hubble Space Telescope, can collect high-resolution spectra and detailed imagery over several months, instead of the brief observation windows we're used to with interstellar visitors. Such comprehensive data provide invaluable insights into primordial materials and formation processes from other star systems, potentially preserved unchanged for billions of years during the object's journey through interstellar space. The massive international collaboration studying 3I/Atlas really exemplifies modern astronomy's remarkable capability to rapidly coordinate global resources and expertise when investigating these transient cosmic phenomena. Scientists actually anticipate that discoveries from this visitor could fundamentally reshape our understanding of planetary formation, the prevalence of organic compounds throughout the galaxy, and the dynamic processes that shape stellar systems. All in all, 3I/Atlas is shaping up to be an unprecedented scientific treasure trove, with implications extending far beyond our solar system's boundaries. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to terrify scientists despite months of intensive study and observation? The most experienced researchers admit that critical questions remain frustratingly unanswered, creating unprecedented uncertainty in the astronomical community. Scientists struggle with determining the object's precise dimensions, as the dense coma extending up to 24 kilometers across completely obscures the solid nucleus, leaving size estimates ranging wildly from 0.8 to 11 kilometers in diameter. The object's anomalously early cometary activity, beginning at over 4.5 astronomical units from the Sun, directly contradicts established thermal evolution models for icy bodies, suggesting either exotic ice compositions or unknown internal heating mechanisms. Spectroscopic analysis reveals compositional anomalies that defy conventional explanation, with water-ice signatures that don't match expected patterns and electromagnetic emissions that hint at non-natural materials or energy sources. Perhaps most disturbing is the object's apparent structural integrity, despite an estimated age exceeding 7 billion years of interstellar travel, which should have resulted in significant fragmentation and erosion from cosmic radiation and micrometeorite impacts. Advanced computer modeling has failed to adequately explain how natural formation processes could produce an object with 3I/Atlas's specific combination of characteristics, forcing scientists to confront possibilities that challenge fundamental assumptions about cosmic physics and the nature of interstellar space, leaving the scientific community genuinely uncertain about what they're actually observing. The alien question. Could 3I/Atlas represent humanity's first confirmed encounter with extraterrestrial technology? And, why are some scientists genuinely terrified by this possibility? This question has sparked honestly unprecedented controversy within the astronomical community, dividing respected researchers and really challenging the boundaries of acceptable scientific discourse. Prominent Harvard astrophysicist Professor Avi Loeb has courageously argued that the object's statistically impossible trajectory, precise planetary encounters, and anomalous physical characteristics strongly suggest artificial rather than natural origins, potentially representing advanced reconnaissance technology from an extraterrestrial civilization. Loeb emphasizes that the mathematical probability of 3I/Atlas's trajectory allowing optimal study of multiple planets approaches 0 for random natural occurrence, suggesting deliberate design for comprehensive solar system reconnaissance. His analysis points to the object's strategic timing, noting it remains hidden behind the sun during closest approach while deploying what appears to be controlled outgassing for course corrections or communication purposes. However, the majority of mainstream scientists express deep skepticism about artificial origin theories, emphasizing the importance of rigorous scientific methodology and warning against premature conclusions that could undermine public trust in astronomical research. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide definitive proof of intelligent construction. Nevertheless, the artificial origin hypothesis continues gaining credibility as conventional explanations fail to account for 3I/Atlas's unprecedented characteristics, forcing the scientific community to confront the, terrifying possibility that we may be witnessing our first confirmed contact with alien intelligence deliberately studying human civilization. Observing the visitor. How are the world's most powerful telescopes being mobilized to unlock the secrets of 3I/Atlas, and what are they revealing that has scientists so concerned? Astronomers worldwide have initiated the most comprehensive interstellar object observation campaign in history, deploying virtually every available telescope and detector system to study this mysterious visitor before it disappears forever. Ground-based observatories including the Gran Telescopio Canarias, Palomar Observatory, and Gemini South provide continuous optical and near-infrared imaging, while space-based platforms such as the James Webb Space Telescope, Hubble Space Telescope, and various planetary mission spacecraft contribute unprecedented high-resolution data across the electromagnetic spectrum. This coordinated international effort involves over 30 observatories and research institutions sharing data in real time, creating the most detailed observational dataset ever assembled for an interstellar object. Sophisticated spectroscopic monitoring reveals temporal changes in outgassing patterns and dust production that suggest controlled rather than random thermal processes, while polarimetry studies indicate surface properties inconsistent with typical cometary compositions. Radio telescope arrays including Arecibo and the Very Large Array continuously monitor for potential electromagnetic emissions or communication signals, though results remain classified under government security protocols. Advanced computer processing analyzes terabytes of observational data searching for patterns that might reveal the object's true nature, with some preliminary results being restricted from public release. The unprecedented scope and intensity of this global observation effort reflects both the scientific opportunity and the underlying concern about what humanity might be encountering in 3I/Atlas. Dawn of a new era. How has the discovery of 3I/Atlas fundamentally transformed humanity's approach to cosmic threats and our understanding of galactic dangers? This latest interstellar visitor marks a dramatic evolutionary leap in our species' ability to detect, analyze, and potentially defend against visitors from beyond our solar system. Advanced automated sky surveys including the Atlas Network, Pan-STARRS, Catalina Sky Survey, and the soon-to-be operational Vera Rubin Observatory have revolutionized interstellar object detection from once-in-a-lifetime events into regularly observable phenomena that require constant vigilance and rapid response capabilities. This technological revolution extends beyond simple detection to include sophisticated threat assessment protocols, international coordination mechanisms, and classified defense planning scenarios that acknowledge the potential for hostile interstellar visitors. The Pentagon's All-Domain Anomaly Resolution Office has quietly established new protocols for evaluating objects like 3I/Atlas, recognizing that future visitors might not be as apparently benign as current examples. Future space missions are already being planned to intercept or rendezvous with similar objects, potentially including defensive capabilities should such visitors prove threatening to human civilization. As global scientific and military institutions adapt to this new cosmic reality, humanity stands at the threshold of an unprecedented era where the mysteries of deep space directly impact planetary security and survival. The age of interstellar object research promises to fundamentally reshape not only astronomy and space science but also defense strategy, international cooperation, and our species' long-term survival planning for decades to come, as we finally acknowledge we are not alone in a potentially dangerous galaxy. As 3I/Atlas races toward its October encounter with our sun, carrying secrets that could forever change humanity's cosmic perspective, one thing becomes clear: we are no longer alone in monitoring our solar system. Whether this visitor represents natural wonder or something far more extraordinary, we stand at the threshold of discoveries that may terrify and transform us. Stay tuned to Space Facts for the latest revelations about our mysterious cosmic visitor. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community: a mysterious object traveling at impossible speeds through our solar system. Meet 3I/Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I/Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I/Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely. Possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I/Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I/Atlas joins an exclusive club that includes only one Oumuamua and two Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the Sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific goldmine. Why are astronomers around the world calling 3I Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration, raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3Y Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optic systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the Sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share and subscribe to Space Facts, where the universe reveals its most astounding secrets.